In this video, you will learn how to simulate a multi-body metal forming process called clinching using the isothermal analysis module of AFDEX 2D, the Intelligent Metal Forming Simulator. Let's get started with the process type first. Since the geometries of the workpiece and the dies are axisymmetric, we will carry out a 2D axisymmetric simulation. The temperature change is neglected in the simulation, that is, this will be an isothermal finite element analysis. The information about the material is given on the left side. The dimensions of the workpiece are as shown in the figure on the left. The material of the workpiece is an aluminium grade and its initial temperature is equal to that of room temperature. Soap-based lubricants are used in this forging process. Therefore, a corresponding friction formulation will be selected. A constant velocity condition will be used in this simulation because the material is rate independent. The upper die will move downward with a constant velocity of 1 mm per second and the lower die will remain stationary. A blank holder force of 100 kN will be imposed on the binder die. The problem definition is complete. The result of the simulation can be seen on the right side. The two aluminium sheets will be joined without the use of any additional components such as a rivet in this process. So now, let's see how we can simulate this clinching process using AFDEX. Double-click on AFDEX icon to execute AFDEX in your computer. Click on New to define a new process. In this process information window we will clearly define the process type. This is an axisymmetric cold forging process. So we will make the selections accordingly. Select cold forming and 2D axisymmetric simulation. We select Newton as the unit of force. So the unit of stress will be megapascal. This will be a flow analysis, which means only the mechanical effects of deformation of the workpiece will be considered in the simulation. Select elastoplastic deformation type. This means the elastic component of deformation is also considered in the simulation in addition to the plastic deformation. Since this process does not have any flash, select regular type under flash. Click OK. This is the main window of AFDEX. We will use the toolbar to set up the simulation step by step. First step is to import the geometry. Click on Model, from File and then select the geometry file in DXF format. Click Open and then click OK. Click No to not make the overall process automatic. We will assign the geometries to the dies, manually. Note that you can get this geometry file inside your AFDEX installation folder. Let's move on to the second step, which is to define the material property. Click on Material, from Library and then select the aluminium grade A_6063, T equals 20 degrees Celsius, _M1 and then click Load. This will load the material into the simulation. Now click Close. The third step is to define the press machine type. As you know, we will use a constant velocity press. For using that, click on Press, Manual, enter -1 in the fifth column of the table. This means, making the press move downwards, in the negative y direction, with a constant velocity of 1 mm per second. Click OK. The fourth step is to select the friction formulation. Click on Friction, from Library and then select soap_cold, aluminium, click Load and then Close. The next step is to define the blank holder force and the force exerted by the ejector on the workpiece. For doing this, click on Die Type Manual. Select Binder versus Time from the drop-down list. Click Add twice. This will add 2 new rows for data entry. Now enter data as you see on the screen. For a time of 0 second, enter a force value equal to 100 kN. For a time of 10 seconds, enter a value equal to 100 kN. Click OK. Since this is a multi-body process, we need one more workpiece. For this, right-click on Stage 1, and click on Insert and then click Workpiece. Similarly do the same for inserting one more upper die. Make sure that you have 2 workpieces and 2 upper dies and 1 lower die in total. The properties that were loaded so far will be assigned to the respective entities now. Select the geometry file starting with mold 00_2D, drag it and drop it over upper die. Select the geometry file starting with mold01_2D, drag it and drop it over upper die 2. Select the geometry file starting with mold02_2D, drag it and drop it over workpiece 2. Select the geometry file starting with mold03_2D, drag it and drop it over workpiece. Select the geometry file starting with mold04_2D, drag it and drop it over lower die. Right-click on the aluminium grade and select to workpieces. This will assign the material grade to the workpiece. Select V equals 0, -1, 0, drag it and drop it over upper die. Right-click on soap_cold, aluminium, and then select to upper and lower dies. This will assign the friction formulation to all the dies in the simulation. Select binder 1, drag it and drop it over upper die 2. Now we have completed the definition and assignment of properties to the dies and the workpiece. The next step is to position the dies properly. For this, we will use the Positioner tool of AFDEX. Double-click on Stage 1 and click on Positioner icon on this toolbar. Select Workpiece and click Drop. This will drop the workpieces on top of each other. Click Auto icon now. This will enable automatic positioning of the dies. Click OK. The next step is to define the properties such as stroke and number of solution steps. For Stage 1 stroke definition, double-click on Forming 1. This will open the Forming Control window of Stage 1. Select Time from the drop-down menu next to Stop Criterion and enter a value of 4.75. This is the stop criterion for the stage, meaning that, when the process time reaches a value of 4.75 seconds, the solver will automatically stop the simulation. After doing this, click on Output Divisions. We will increase the number of solution steps used in the simulation. Select User defined below number of solution steps. Enter a value of 300. We will also increase the number of elements used for meshing. To do that, click on Volume/Mesh and then select User defined. Enter a value equals 3000. Now click OK. The next step is to set the coefficient of friction values at the interface between the workpieces. To do this, right-click on the DXF file below Workpiece. Select Friction and Initial State Value. Make sure that a value of 0.1 is entered and click OK. Similarly, right-click on the DXF file below Workpiece 2. Select Friction and Initial State Value. Make sure that a value of 0.1 is entered and click OK. We are almost done with the simulation setup process. We just have to save the simulation, check, and run it. Click on the Save icon, enter a file name. And then click Save. Your simulation file is now saved. The final step is to check the simulation to see if we have set it up correctly. Click on the tick mark button on the toolbar. In the window that opens, click Check. This will let you know the error messages if there are any. There are no error messages in the simulation, but we can see that there is a message in the Notice section. Click on that number to see the details of the notice message. The message claims that information about velocity has not been defined for one of the dies as there is no press data. This notice message can be ignored though. Because if a user does not define velocity for a die, AFDEX automatically assumes the die to be stationary. After making sure that there are no error messages, click Run. This area shows stage-wise and overall progress of the simulation. On the right side are the different state variables that can be visualized based on the simulation. You can explore more on this section to investigate the state variables of your interest. The media tools here allow you to visualize the deformation behavior of the process.